Okay, as we continue with probability, we have the conditional probability. And what that is when we have two dependent events, and I've got the notation here is the probability of B, or I'm sorry, the probability of event B given that event A has occurred. So that is how we look at this, and so again, they're dependent on each other. And when we look at this information, it's asking me here, looking for finding this conditional probability. What is the probability of a student being female given their graduate students? So if we look at this information, we look at this table over here, and it talks about our genders, and we know that this, here you go, you got male students, you got female students, and we're talking about given graduate students. So all of my graduate students, will add those together. So the probability of the probability of the female and a grad student is going to be equal to, well, how many students do we have? Well, I believe these two added together are going to give me 3,303 students total. And now how many of those were female? So here you go, female. So that's given the grad students, given event A is grad students, event B is going to be their female. So I have 1,954, which is going to give me approximately 0.59. And that is the conditional probability of the probability of female students given grad students. And then what is the probability of females? Let's see. Well, looking at our information, we have the total number of females is going to be, let's see, total number of females is going to be 2462. That's horrible. So the what is the probability of it being a female student? Well, we take all of our female students and we divide that by all of these students completely. So how many students do we have, and then how many students occurred to be female? And that is going to give us something along the lines of, bring that down here, I think we have 9,933 female students, and we had 17,472 students total, for a conditional probability of 0.57. So we're starting to use conditional probability based on two events occurring. Let's see here, conditional, let's see here. Americans recycle increasing amounts through municipal waste collection. What is the probability that a sample of recycled waste is going to be paper? Well, I think here, wouldn't we have to, one, of course, figure out how much recycled waste we have, and then how much of it is paper. So given the amount of recycling, this would be recycling, and then this would be my paper. So I'm hoping then we would have 45.2 paper over the total amount of recycling. So let's see here again, Americans recycle increasing amount is a probability that the sample of recycles is paper. And I think that should probably be recycled waste is paper. It's a typo on my behalf. So add these all up. Okay, so adding those up, I have a total of 79.4 million tons of recycled waste. And of course, the amount of paper was 45.2 divided by the total amount here, and that's going to come to 0.57 or 57%. What is the probability that a sample of recycled waste is plastic? Well, again, the number of plastic over total. And then we already know that the total is going to be 79.4, and then plastic came to 2.1. And we should have here, gosh, a very small number, and probably, if you do the math, it's going to be approximately 2.64%. And if you didn't get that, it's 0.0264 as a decimal. And what is the probability that the recycled waste is glass? Again, the total is going to be 79.4. We had 3.2% or 3.2 tons of glass, which is, again, approximately 0.0403 or approximately 4.03%. And I was being a bad example. I went back and put in the proper notation here, where the probability of the recycled being paper, or the probability of it being paper of the recycled, probability of it being plastic of the recycled, and the probability of it being glass given that it was recycled. So just wanted to add that in there because that's the proper notation that you should be using. And then as we come over here, we're looking more about conditional probability. And so we're looking here, a utility company asked 50 of its customers whether they pay their bills online or by mail. And then what is the probability that a customer pays the bill online given that the customer is male? Okay, what do we know here? Total customers, not a good color. Total customers, 30. No. Total customers, 50 total. And let's see here, the probability of paying online and mail. So the probability of online and mail, so is the, I guess here, the probability of mail and online over the probability of mail. I guess we need to look at it that way, of all the mail customers. So we have the probability of mail and online is going to be 12 of 50, and then the probability of being male is going to be 36. No, that would include females. Sorry, I was going the wrong direction. 20 of 50, and that is going to simplify, of course, to 12 over 20 or 3/5, which is 0.6 or 60%. And that is the probability that a customer pays online given that the customer is male. Okay, and let's see here. Researchers asked shampoo users whether they apply shampoo directly to the head or indirectly using a hand. What is the probability that a respondent applies shampoo directly to the head given the respondent is female? Okay, so the probability of the female and online based on the probability of being female. And I said online, I think I meant on head. So because it was directly onto the head over the probability of a female. So we have, well, female and directly onto head is 6. Okay, 6 out of 50. And then, of course, just being female is going to be 30 out of 50, or we're looking at 6 out of 30, and that is going to be equal to 1/5, or 20%, you know, this is, of course, 0.2. And there you go, that's the probability, given that the respondent is female and puts it directly on head. See here, using a tree diagram. This is going to get a little bit more difficult. Not more difficult, just something more visual to see as you make your decision trees. So we are talking here, school system compiled the following information from a survey that was sent to people who were juniors 10 years earlier. So 85% of the students graduated from high school. Of those students who graduated from high school, 90% were happy with their present jobs. Okay, so we are going to start somewhere. Start right here with those individuals. So we know that we had two subsets. We had graduates, and then we had not graduates. And then we knew that 85% of the students graduated. So we know that this is 0.85, and if that's 0.85, then we know that not graduated is going to be 0.15. Then of the students who graduated, okay, we have another chain here, from high school, 90% of them are happy with their present jobs. Okay, so we know then that this one is going to be happy, and this one's going to be sad. And we know that 0.9 is happy, and we know that 0.1 is sad. And then if the students did not graduate from high school, 60% are happy with their present jobs. Okay, for those people who didn't graduate, we know that 0.6 are happy, and we know that we have some sad people out there, and that's going to be 0.4% of the people. And what is the probability that a person from the junior class 10 years ago that we're talking about graduated from high school and is happy with his or her current job? So we are looking at the probability that they graduated and they are happy. Okay, so we have the, let's see, the probability that they graduated times the probability that they are happy based on that they graduated. Or, they graduated, so it's the pool that graduated from there. And that is going to give us, let's see here, the probability that they graduated is 0.85%, or 0.85, and then the probability that they graduated and they are happy, which is going to lead us down this point, is going to be 0.9 times 0.9 is going to equal 0.765, or 76.5%. That is the probability that they graduated and they're happy with their job. And let's see what else. So we have the probability here. What is the probability that the student from the junior class 10 years ago did not graduate and is happy? Well, we need did not graduate and is happy, which is going to be the probability of the not graduated times the probability of happy, and that's going to give us not graduated is wrong button, 0.15 times the probability that they are happy, which is 0.4, and that's going to give us a total of 0.6. I just messed that up. That is 6%, 0.6, I'm sorry. And then we have, that is going to be equal to 0.09, or 9%, because we have 0.6, 0.15. Okay, multiply that out. So there you go. There's your conditional probability that they did not graduate and are happy. So when dealing with conditional probability, just remember that those are dependent factors based on one another, and very simple to process through the work.